Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate what is end behavior. Well, end behavior is a way to just describe the behavior of the graph as x approaches positive or negative infinity. So I have 4 examples here. Let's get started. Y equals 3x plus 2. So I'm just going to do a random sketch of it. There it is. It's linear, right? So what we're going to do is we're going to look at it and go, what happens at the ends? We never look at the middle. So we're going to describe it. So as x approaches positive infinity. Now look at your graphs. So positive infinity on the x-axis. Let's get some color codes here. Positive infinity is on here. So if I go all the way to the right, I'm headed to the positive side of numbers. If I go up forever, that's positive infinity on the y-axis. If I'm going to the left to the negatives forever, that's negative infinity. And if I go down forever, that's negative infinity as well. So as x goes this direction here, okay, so if I go along the x-axis, what are my y coordinates doing? So I'm just curious about the ends. So the end is right here. So if I look at Desmos, I can see my y coordinates continue to grow forever. So as x approaches positive infinity, my y values are also approaching positive infinity. So the arrow icon means the word approaching or approaches, okay? Now, when we talk about end behavior, we just talk about the ends. We don't care about what happens in the middle. So let's look at the other direction. So what happens as x goes to negative infinity? So if I let my x values go to negative infinity, so let's look at Desmos here, what happened to my y values? They're continuing to grow to negative values forever. They don't stop. So as x approaches negative infinity, my y values also approach to negative infinity. So this is the end behavior. We're describing how the behavior of the ends of the functions work, okay? So now let's look at another function. So again, let's look at the behavior of the ends of the functions. Let's start with the positive infinity inside. So start at the origin, as x approaches positive infinity, so as it goes in this direction, what is my graph doing? My y values, as we can see here, my y values are getting larger and they're headed. We can see the graph is actually pointing to that positive infinity. So we're going to say y approaches positive infinity. What about as x approaches negative infinity? So now we're going to go on the negative side. So let's look at the graph. As my x values go to negative infinity, what is my graph doing? It's also pointing in that positive infinity side. The y values are doing that. And we can check that on Desmos here. We can see the y coordinates as my x's become more and more negative, my y's are still continuing to increase. So in this example, the end behavior is the same. In the first example, the end behavior is opposite. Now, that is not coincidence. Notice what is my degree in this one right here. It is even. So even degrees have same end behavior. Odd degrees have opposite end behavior. So in this example here, this was y equals 3x plus 2. In this example here, this was y equals x squared minus 3. See, so the degree here is 1. That's odd. So the end behavior was opposite. And in this case, the degree was even. So notice the end behavior was the same. Let's look at a couple more here. So this is a cubic. So the degree is odd, so it makes sense to us that the end behavior is opposite. So let's do a quick sketch of it. So let's try our end behavior. As x approaches positive infinity, what are my y values doing? So as x goes this way, as we put in positive numbers, what is my graph doing? Notice it's pointing to that negative infinity side. Now let's try the other direction. As x goes to negative infinity, what is my y values or my graph doing? That's this piece right here. It's pointed up to the positive infinity inside. Now notice I don't care about what's happening in the middle. Again, end behavior only talks about the ends of the graph. If you have to, cover up the center and just look at the ends like that. I have one more for you. This is a 6th degree polynomial. Now let's try and do our end behavior. So as x approaches positive infinity, so start at the origin, move to the right to positive infinity, what is this piece doing? It is pointed down to negative infinity. So y approaches negative infinity. Let's go to the other side now, the other direction. As x approaches negative infinity, my piece of my graph here is pointed down towards negative infinity here. So there you have it. Now, notice I told you this was a 6th degree function. So it makes sense that the end behavior was the same. This was an odd degree function. So it makes sense that the end behavior was opposite.